Alright, let me disconnect from Hank. And yeah, just give me a link on Twitch and I'll just get in ASAP.
Should I just keep both going, or is the bandwidth going to be so bad?
No, I don't think that's a problem with Twitch though. You can keep things on.
All right, whatever. I'll keep Twitch on.
Yeah. I just don't have your Twitch link though.
Oh, sorry. Let me get
I
that.
don't know.
Twitch. Oh no. One sec. This cat.
Okay, there we go.
This cat is angry. Hold on. Just gotta check this cat. What's wrong,
Sure.
Boopo? What's wrong, little chicken? What happened here? Everything looks good. I don't know. He's.
Okay, yeah, I'll mute your Twitch and look at the screen. But it's all right. I think it's going pretty smooth over there. It's pretty responsive.
Yeah. Okay.
Oh yeah, it's smooth as hell, dude.
And it's 4K, which also is nice.
Yeah.
Or whatever, 1080. Yeah.
Okay.
Get this fucking thing in. Fucking fell out. Hold on a sec.
Sure. Yeah. Oh, by the way, is this like notebook format? Something you just write all your script down in and like just run it like at the same time, or is it like I don't know, like a console kind of thing?
So you can set auto runs on scripts, and you can do applets, and it gets pretty advanced. Yeah.
Okay.
So you like if you wanted something to auto run, you do
Mhm.
cell, and then you basically do cell properties, initialization cell you could set, or an initialization group, and that'll run as soon as you open the notebook. So yeah, you can even have those cells be hidden. So if you send someone the notebook, they don't see all the library code you've written. They can just yeah. You can do a lot of complex shit, but it's and you could even like use Wolfram's C bindings to use Wolfram code. Let's say run a web server and stuff, but I don't know if the greatest use is doing that kind of stuff. It's really got strong
I see.
suits for more like of the notebook sort of, a little bit more trivial stuff, you know.
Mhm.
I've done stock analysis and like file parsing and more advanced stuff, but it hasn't been stuff where you want to reproduce it and send it to people. Like you really want to more so use compiled languages for that kind of stuff, you know.
Mhm.
So here, let me show you what I mean by functional. All right. So
Sure. Yeah. Go ahead.
I'm not gonna use fancy symbols now since they'll probably just confuse you. I'll put the brackets back. So we don't use
Sure.
parentheses in Mathematica. We just use the brackets so you can see.
Okay. Square brackets.
Yeah,
Gotcha.
that's a function in invocation. And interesting thing is here we can use head, right? And
Yeah.
sorry, I shouldn't use those ads. We can use head and it'll grab H, right? And if we tried to, let's say, grab the tail, or sorry, not head. Hold on. Let me open up docs real quick. And so if we
Sure.
type in head, we can actually get the section that operates on expressions. So we could do level, for example, gives a list of all sub-expressions. So for example, you have this and you want to grab -1, right? So
Mhm.
watch level, right?
Okay.
Let's grab 1 first, right? And that's just this inside, right? How about 2?
Okay. What is the curly bracket for then?
So curly brackets is a set. It's an array.
Oh. Okay. All
Yeah.
right.
It's not a set. Sorry, it's an array. It's an ordered sequence, a tuple.
Mhm.
And here's 2, right? Level 2. Now we could do 3, right? And that would be x and y, but we could even do 3 comma 1, or sorry, not 3 comma 1. We have to put that in. Oh wait, sorry, hold on. Level spec. Let me just take a look. 3. Oh, okay. So it would be 3, right? But then we can just peel it off after and get which internal level we want. But there might be actually ways to do it nested within the function itself. Let's see. A lot of these functions are very overloaded. You'll see that a lot in Mathematica, where they can do a ton of different things. It's just that you have to sort of you gotta read the docs and sort of see what's the power of the function.
Yeah, I'll eventually recognize the pattern that's going on in here, but holy hell, dude! You know what? I'll just wait till your actual streaming starts and everyone gathers around. So I'll just have like a grasp of things at like the basic level, right? And we'll go on from there.
Okay,
How's that
but
sound?
all I wanted to show you is basically the way Level is doing this, right? Is it's has a hold on its first argument, and what that means is that it just gets literally this, not evaluated. It gets the code itself. So that's what a functional language really has a strength in. But that's not what functional refers to all the way. Like I was saying, in programming language like C# and more procedural ones, there's still functional programming. And that's just dealing with arrays and big pieces of data and sort of manipulating it as a stream. For example, like if we want to map over, let's say, a range, like the first 10 numbers.
Okay.
And also, you can hit F1. Well, it depends if you have the desktop or you have the.
Yeah, I've got the desktop one.
So you hit F1 after highlighting a function, and you'll get the documentation for it. So essentially, we have. I sometimes get this wrong, but clearly it's the function you want to execute is the first argument. The second is the list, the array, and you basically can do something like this, like f. Let's say f of x. Yeah, f of x equals, I don't know, 2 times x, right? Run that. And then I'll map f over the range. Boom, I'll get that.
Okay, wait, what's that x underscore? That means that you defined x to be a simple variable of this function?
Yeah, so the way arguments for functions, where function definitions work in Mathematica, is there's a couple different ways to define them. I'm gonna teach the class this way because it's a bit simpler, but essentially you have a label and then you have a pattern, and the pattern can be quite a variety of things. So, for example, if I did this instead, right? If I put 2 underscores, watch what happens now when I run f on, let's say, 2, 3, 4. So what happened was it took the whole list, right? And that became x. And then it multiplied 2 by x. I'm actually not sure why it's 48, but let's see, 2 times 4 is 6. I think they all got multiplied. But essentially, if I just set it to x here, you see it's a sequence, right?
Yeah.
Which means we can do a lot of things with it. If we convert it to a list, right? And then do it again. Now we can just manipulate it. Like, I don't know. I want to let's say just multiply all the numbers, right?
Yeah.
So I can do times at the list. Boom. So it's sort of like in C++ and those languages, you can do var args. So even though there are 3, we didn't do x, y, and z, we can have a var number. So that's why there's an underscore. It's because more is happening than you just specifying a variable. There's a lot of power here that I'm not going to teach the class at all this first time because this will just confuse the fuck out of them. But there's a lot of power. When they ask what's the underscore, I'm just going to tell them that's the way it is.
Yeah, obviously.
Yeah, so...
I mean, I don't even get what... Yeah, I just don't get it myself as well.
Yeah,
But
so
yeah, well, yes,
here's the
I'll
underscore.
figure it out.
Let's see, blank. So here you go. So blank or blank is a pattern object that can stand for any expression. And then you, of course, have this introduction for patterns, which shows you that you have blank, which stands for anything. You have double underscores, which stands for a sequence. You have question mark things to specify. Let me see if I can find that. Rules and patterns. Gets really advanced. So here's the different ones. Here's what I want to show you. So you have blank, any expression, easy peasy. X or any variable name, and then the blank, any expression referred to as that variable.
It's X. Uh-huh.
Um,
Okay.
double double underscore is a sequence, any sequence of one or more expressions, which comes out like we saw as what's called a sequence object, which, as you can see, when you multiply a sequence object, right? Um,
hmm
hold on, I fucked that up?
Okay, yeah, so, but that double underscore, you defined the X as a sequence of different
So
entities.
I define that as a sequence. That means when I execute it right here, it gives me 2, 3, 4, 5. And if I took this, right, you know how we had 2 times before and we were like, what the fuck happened? Well, apparently sequence objects have, like a lot of objects, the way you can define your own. And the way that Mathematica might define them is that so for example, let's say we have an array, right?
Mhm.
And I multiply this by 2. This is a sequence object or a list object. Mathematica has put in behavior such as when a list is multiplied, it
But,
yeah,
okay, so each of the members are separately multiplied by that constant. But
right. But it doesn't
if
happen for a
you,
sequence. Sequence is a different
Mhm.
kind of object, and I actually don't
I
know
see.
what it did here. I think it multiplied all of them together because 2 times 3 is 6, 6 times
Oh
4 is
yeah,
24.
probably.
Yeah, 24 times 5 times 2. Yeah, that's right. It multiplied
Mhm.
everything together. So,
Yeah,
um,
I
so
getcha.
yeah, it has a
So
different.
sequences and sets are different types of
They
objects.
are,
I
yeah.
getcha.
It's a little counterintuitive, but the nice thing is you can always convert a sequence to a list by just applying the list constructor to it, and then we'll get our standard behavior of what we wanted.
Mhm. I see.
So here's the other patterns that you can do. A condition. You can have a test. So for example, if I did x underscore, right,
Mhm.
and then I put a number, or let's say I just put even q, right, which is testing if the number is even. And I could say if it's even, then let me just kill the kernel to reset the
Sure.
variables. Okay, so
Mhm.
if it's even, I'm gonna say okay, I'll take 2 times x, but I'll also define, um, so I'll define that, right, and then
Mhm.
I'll define another definition for it called odd q with odd q as the test. And oops, sorry, I was supposed to change that to 3 times, so we have something
Okay.
different. I'm gonna delete all this, and here we go. So if I did f of 2, we should get 4. Perfect. What about f of 3?
Mhm.
It should be 9, right?
Oh yeah,
The fuck's taking so
I
long?
get you. So you can even put like conditions
Yeah,
just right there.
you can put
Okay.
conditions right in your definitions of your
Wow.
functions. Um,
That makes it pretty like compact, actually.
yeah, so you can have things being overridden to make it easier. Like if it's greater than 7, you see this one right here, condition. See, I don't
Yeah.
even remember the syntax for a lot of these things. That's why I'm looking, and I hope you forgive me for that. Um,
No, it's all good.
so here we'll do one where if x is greater than 7, it's going to be
hmm
4 times x. This should override the previous two, I believe.
Well, yeah, because those previous two were really generic conditions, so is a more specific one, and it should.
Actually,
Yeah.
it doesn't override. There's something you have to do to basically. I think we might have to define this one before the others. So here, let's try that real quick.
Sure.
Order of operations. because they're conflicting sort of definitions. So there's better ways to clear variables, but I'm not gonna do them right now. So if we did f of 8, should be 32. Perfect. F of, let's say, 3 should be 9, and f of 2 should be 4. Yep. So the order does matter in some respects, but you'd always figure it out if you fucked it up anyways. Just a lot of like little things to learn in addition to all the crazy powerful stuff, which I still don't know everything. All this pattern stuff, I don't remember at all.
So the condition order is kind of similar to the what you call it, the fizz-buzz problem. Buzz fizz or fizz-buzz.
Ah, yeah, right.
Yeah.
If it's
Remember
if
what
it's modulus
There-
this,
There's that like exactly. There's like this critical thing about conditions orders.
we could actually do that right now if you want to see maybe the way to, because it's like you said, the reason I think it's pretty powerful is because you can write things really, really slim and short in this language for all the tools it gives you.
Yeah.
Let's try that actually. Let's see.
Sure. Yeah.
FizzBuzz. I forget the.
So
There's a lot of
think it
people
was something
joining.
like. Yeah.
Sorry, what were you gonna say? You think it was what?
I think the fizz-buzz problem was something like if that number is, I don't know, divisible by like this, I don't know, one prime number, I don't know, let's say 2 right fizz, if it's only divisible by, I don't know, another prime number, let's say 3 type, I don't know, buzz, and if it's divisible by both of them, which would imply that it's divisible by 6, it should write both like fizz buzz, you know what I'm saying?
Mm-hmm.
So you'd have to put the more specific condition before the other two. Otherwise, if you put the generic ones first, so if you for instance put the generic, I don't know, if this is divisible by 2 before, if this is divisible by 2 and 3, it's just gonna, and if you do an input of, I don't know, 6, it's gonna get caught in the first generic condition, and it's just gonna type in fizz, right? It's not gonna type in fizz buzz, right? So I'm just saying in that kind of sense, the order of conditions matter, right?
For this one, yeah. If we did it with those function specifiers, trying to think what would be the most concise way to do this. So.
But I don't know if this is the same thing for this type of programming as you call it, like functional programming, because I'm really used to procedural.
Yeah, so I think you're right that this way would actually probably be the way to go for like, I think, let's see, 5 mod 3. I don't know if parentheses. Yeah, parentheses. So you have to use the mod function here. The percent sign has a different definition in this language.
Okay.
So we're gonna do if mod x 3 if that's equal to, we could just do divisible x3. That returns true or false, this function. Usually the true or false functions have q in front of them, but you won't always see that because.
All right, so if x is divisible by 3, then
We got fizz, right?
and define this as the output. Okay.
If it's divisible by 5, we have buzz. And then we have, is that it? Isn't there another one?
Yeah, fizzbuzz if it's divisible by both of them. So you should put the more specific one before the generic ones. Or I don't know, just
Oh,
put it
okay.
after those generic ones. I don't know, giggles.
I see what
or
you're
something.
saying. So if divisible by 15, then
Mhm.
fizz buzz.
Yeah, I want to see if it gets caught in the generic conditions or not.
And then if it's not, it's just the number itself. So we can just put f of
If
x.
it's not, then just don't do anything.
Um,
Well,
you don't do anything?
yeah, just don't do it.
I'll just put this here.
Is that like an else expression?
Yeah,
That's like a default expression for that.
yeah. I mean, because it's the least restrictive. So if it goes through all other three, then it'll get to this one. The funny
All
part
right.
is we're not even like this isn't getting executed. It's not like this is the body of a function. It's just a bunch of what's called patterns that we're setting, and this should do it. So here's what we'll do. We'll just do range, right? We'll do map, and if you want to do a map shorthand, you just do /at. So you do f/at range. Let's say first 100 numbers. That did not work the way we're supposed to.
Okay, so you're just making like an array for the inputs. Is that what you do?
Oh, sorry, what's that?
You're basically making this array for inputs, right?
Yeah, that's right. Hold on.
Yeah, if at range one. Okay, range 100 itself, it's like a set from 1 to 100, right?
Yeah. Oh, you know what? We have our previous definitions that are overriding. Here, so
Okay.
if you want to clear out variables in Mathematica,
Mhm.
I believe it's, let me see, delete, or no, not delete, clear all. And you do
Oh, okay.
I think it's default or something. Let me see.
Clear all.
Yeah, I'm gonna
Okay.
find out. You basically give it a scope, and then you can clear all definitions. So here we don't need to actually clear everything. We just want to clear F.
Yeah,
So if we want to make it easy, we can just put this at the top to make
create a
sure
definition.
anything else is gone. Okay, so there we go.
I see.
Is this working? Let's see. Uh,
Ah, there you go. Okay, so fizzbuzz. Oh, okay, yeah, and every 15 numbers it just says fizzbuzz. Yeah, that's
Looks like it
correctly
worked pretty
executed.
nice.
Yeah. Right. So just I don't know, mess with the order of the conditions. Just put the fizzbuzz after those separate fizzes and buzzes. Okay. Just
I mean, we could do it with what's called a select, or not a select statement. Um, so let me get up the docs.
okay.
Oh, that's the wrong thing. So we can do, I think is it select? No. So there's a page on logic, but I always, there you go, conditionals.
All right.
So
Okay.
it's, which is going to be the one that we probably want to apply. Let's see. Actually, trying to think what would be the most concise. Because the thing is, we don't really need this fizz buzz for the 15. What we could do is if we collect both the conditions and concatenate them, then we'll get it. So really, I think what we want to do is essentially just want to do something like if divisible by x fizz, otherwise just a blank string, and we could also, and then we can concatenate that with the buzz for 5, and we can go ahead and just stick this in a function. So
I see.
and Yeah, that should work fine. But the number itself, do we have to print that out?
I don't know. Do whatever you want. Maybe.
So,
Oh,
well, yeah, we get a problem there if we don't have a number. So actually, um, we'd probably want to do. I'm trying to think what the easiest way, because what we had before was fine, but you're curious, aren't you? What the smallest we could do
yeah,
anything.
man. Like when I get when something new to play with, I just mess around with.
We kind of want an
See how.
accumulator. We kind of want an accumulator. Um,
Just want to see how it works in like different condition. And,
I think I know what we're gonna have to use. Something with pick.
What's that?
Um,
List-based conditions.
I think I know. So we want to select at least one. At least one, but more than one if
Okay.
there is, right? So let's see. You get what I'm saying? Because if we put these sort of in an array with the number itself, it'll select at least one of them. And so if it gets to the end and it neither fizz nor buzz, it'll select the number itself. So we kind of want something like select at least one with that, and then that, and then just X itself. And that should do it for us. But I don't know if select okay, yeah, select picks out the first n elements for which criteria is true. So that works.
Oh, okay, okay.
So
So it just selects at least one of these conditions that it works.
right, but it should select more than one if given the ability to. So we only want
I mean, you can. Oh yeah, you can either like stick with select at least one thing and just add an additional condition that like below the 3 and 5 divisible thing and put it divisible by 15 for fizz buzz, right? Or
I was
well,
thinking that we apply was it like a concatenation, a string
oh,
concatenation
okay.
to
Oh yeah, but
all the ones it picks.
okay, so sure, yeah.
But I still don't know how we're gonna select at least one because first n elements for which it's true. Hmm. Select first. Default. There we go. Yeah. Well, we could just do that. That would work. This is an easy way, but then we'd probably have to
Ah,
put the fizz and the buzz in there. So let's see. This one doesn't have a default. That's the issue. Um, we could do a default with an if statement, but I think this is probably going to be our best bet. So I do select
probably.
first, and we'll basically have the 15 one in there. We'll basically have 15, 3, and or 15, 5, 3.
Yeah, or 15.35.
Yeah, either way, the order shouldn't matter for those, right? And we're gonna select uh, the criteria is gonna be divisible x by. This is called a pure function. Um, yeah, if it's divisible by m.
Oh, what's that like pound thing over there?
Oh, sorry, what's that?
The number logo in
That's
front of the
so
in the
that's
divisible.
so it's basically a pure
Oh yeah,
function.
that one.
So here I'll show you what I mean. So we didn't specify a default. That's why that's fucked up. The default's gonna be just x. Um, so well, so you see, we have to replace these though. So we basically want to do something like well, that's gonna be a problem actually. Or actually, we could just do, I guess, 1. Right? We could put 1 here, and then we could do a pattern expression where we do 15 goes to FizzBuzz, 5 goes to was it Buzz, and 3 goes to
Oh yeah.
Fizz, and then 1 goes to X.
Yeah, I guess this is kind of pretty wacky, you know.
Yeah, this is worse than the first one, but there's ways to do it. It's just
Yeah.
I'm not gonna find the perfect function right now to do it.
Yeah,
But
don't worry about it. It just kind of shows that it's a pretty like, flexible language. You can have your way with it.
yeah, so this right here is a replacement. So we can actually, if you see, if I run it again, right? This is what came out, right? I can actually take this right here, right? And sorry, was it Mathematica reference last value? It's just like JavaScript console. You can do parentheses, or sorry, percentage sign. What's the
Yeah.
actual name for this? Is it percentage?
Yeah, percentage, I guess.
Yeah, the percent sign. You can just get the last result, the next to last, or as many times as you want to get that many results back, or you could put a number to get that the result on a certain line. So this is 33, so I can just do, I don't have to save it to a variable, I can just do 33 like that. Boom, I get
I
that.
see.
So that's kind of nice too. So you're not always like, oh, I gotta save a variable, you know? It's just automatic for you. So if I apply this replacement pattern to it, you'll see we got what we got. Oh, well, 1 has to go to, I think, or sorry, we gotta go to X. Actually, the number's lost. The number's lost. We didn't save it. We just put 1. We would have had to put, I think, X there. We would have to put something like hold X, and then it gets kind of complex because we need to differentiate whether it's the original number or not. So it'd be like hold goes to.
Yeah, apparently, like when you put like
There.
1 to X there, it just prints out X. It means that like it doesn't have the X saved from before, I guess. Okay.
Yeah. Fuck, I'm not doing this exactly right. I think that should do it, but for some reason X isn't bound here. Maybe it's just. Let me see. No. Why is it a 1? Oh, it's because I'm still doing 33. No wonder. It did work. It's just I'm on
Oh.
%33. Gotta watch out for that. So we want %38, right? And now I should be able to do hold. X goes to X. There we go. Perfect.
There you go.
Yeah.
Right. Oh, there we go. Okay.
It's still just you and me.
All
huh?
right. I guess so, dude. I think you should like put an announcement saying that you started or something.
That I started. Well, it's starting at 11. I don't want to make people.
Oh, okay. What time is it over there?
It's 10:17.
Ah, okay. All right then.
So,
Dude,
is
can
it-
I?
Mhm.
Oh, sorry. Yeah. Go ahead. Say what were
I
you
was gonna
gonna
say,
say?
is the Twitch too laggy?
No, it's perfect actually. It has been perfect from start to end.
But the delay.
So
I
sweet.
mean, is the delay an issue or?
No, the delay's not even an issue, dude. But like when you say something, I see it on the screen instantly. The
Perfect.
thing that you're like talking about, yeah, it's just perfect. Man, I'm gonna go for like a couple minutes break. Okay.
Yeah, of course, man. We've been talking for a long time, so definitely come
Yeah.
back. Come back when you feel like coming back, even at 11. That's fine.
Yeah, I'll come back in like what 45 minutes or something like that.
Yeah, perfect.
That's when it gets started, right?
Yeah, I mean, I'm sure people will start coming in 5 minutes early, but yeah, I mean, it'll start at 11 officially, so you'll be
Oh,
on
okay.
time. That's fine. It's 10:20.
All right.
So
All right.
Yeah.
All right. 40 minutes then. All right, man. I'll see you around in half an hour or something like that.
all right. What's your name, by the way? What should I call you?
Armand.
Armand. All right. I'll see you soon.
Yep. Yeah. What's yours?
Andy.
Andy. Andy. Nice man.
Yeah.
I'll see you around, Andy.
All right, man. I'll see you soon.
See. Ya.
Hi, little Bruce chicken. Oh, you gonna stream with me? My bopin. You gonna come on camera? Let's see, can we get you on? We need to get you on camera. You're a star, Bopo. Yes, little chicken. Nice little cat. Your little boopy cat. We put you a little far back so we can see you. The beautiful chicken. Good little chicken court. Beep bop boop. Beep bop boop boop. My little boop boop. You're a very special chicken cat. Yes, Boopon. The nice little court. You're such a nice court. Here's my Kotick. My little baby Kotick. I'll pet him. Sorry, Boopo. We have things to do tonight. I rub you after, okay, Boopy? Yo,
Yeah,
what's up, you?
not much.
Yo.
Yeah.
Think you have time for one Overwatch match before this thing starts? Think you have time for Overwatch match starts?
Oh my god, there's so much echo with the stream.
Oh, just mute the Twitch.
Yeah, okay.
Welcome to
Yeah, I tried Blackboard. I tried Google Hangouts. We were gonna use Discord, but it only supports 10 people, so
Yeah.
switched to Twitch. I know it's delayed by like 5 seconds, but it's better than the alternatives.
Mhm.
I will prove myself.
It's ironic, I was actually writing a webinar platform for a friend of mine. Too bad it's not done yet.
Is it WebRTC?
Yeah.
Dude, I wrote a conferencing software a while ago using WebRTC for this Rabbi nonprofit. I could actually send you the code base if it may help you with yours.
It might, but we're actually using like another
My barrier's supposed to go.
API based on WebRTC. Not raw WebRTC. I just woke up.
Fuck that guy up.
Giving you a little extra.
That's just skirmish though. So you're a programmer?
A little bit.
All patched up.
Well, you're probably gonna like this language then if you've never been introduced to it.
Yeah, I've been meaning to learn it sometime. I mostly work with web languages, although it's not my favorite.
Yeah, it's nice that there's not many types, you know, it's more free JavaScript. A little bit less stressful, you know.
I don't know, JavaScript is pretty stressful.
Well, it depends who writes it, right? But yeah, I guess. I mean, if you can't really, even if you write yourself, there's always like, well, you know, this convention or that convention, and I'll use a linter and all this shit to try to manage it. But yeah, it gets kind of clusterfucked when there's a lot of code.
I've got you covered. My barrier's down.
I will draw right
Oh, it sounds too high on this game. How much time I got? I got enough time, right?
Welcome to Oasis.
Yeah.
Yeah, sorry, man. I should be like talking to you about code and introducing you, but I just did that for like an hour and a half with the other guys who were in here early. So
Yeah, no, it's fine.
yeah, we're just going over FizzBuzz, how to do it in Mathematica, like the different ways, and I showed them patterns and like all these advanced features that I will never go into in like at least the first 5 sessions, probably.
There's more than one way to do a FizzBuzz.
It's more than one way to skin a cat. That's right.
Alright. I'm gonna go get some water, be right back.
I don't know.
Davison Fox, Minister of Engineering, has a certain ring.
5, 4, 3, 2, 1. Round 1. Capture the objective.
You'll take it in. Take some armor. Shield holding. I'll have to move up.
The objective is now.
Well, that was fucking shit. Jeez.
Back to the drawing board.
Group up here.
for more. My barrier can't take much more. Back to
These
the
people
drawing
are
board.
so fucking bad.
Fixing you up.
Oh my
Best
goodness.
round lost.
Go put up.
Score 0-1.
Now I'll show them.
You were a disgrace to Overwatch. If I had known what Reyes was planning, I would never have allowed it. Time to kill.
Five, 4, 3, 2, 1. Round 2. Capture the objective.
Patching you up. Don't fix that is. I can't this war. Policy quick. Shield will take you damage. Giving you a
The objective is now.
Hey.
Hey, this team is really bad.
I've never really watched or played this game before.
This is terrible. Things aren't going well.
Am I gonna need to like Mathematica account or something?
Yeah, so if you go in the resources chat room, there's a bunch of links. One of them is to sign up for a trial. It takes like 10 seconds.
Alright.
the end of the world.
You don't need to download anything, you just use the online version. But if you send through seminars, I'll hook you up with the full version.
Cool.
I don't even know I thought thinking it was a good idea to play this fucking game right now.
Shield's holding.
This team is so bad. It's just making me angry. Well, at least it'll be a quick loss.
No place to go but up. Reality bends to my will. Take some armor.
I need to put in my whole address to use this.
Nah, just put a fake one, man.
Yeah, I know, but some places just require it. It's why.
Yeah, they probably want to send you some junk mail, you know, upsell, all that shit. Can't really blame him.
Take some armor.
The worst ones, the ones that actually verify the zip codes. You need to come up with a real city.
Giving you a little extra.
Oh, no.
So go from me.
Enemy contact.
Armoring you up.
I love how Junkrat chose me to kill. Just one person. You know, we may actually not lose this one. Probably just when I say that right now, we're gonna start losing.
Fixing you up.
Enemy contact.
Stay outfitted.
Oh, awesome! They didn't verify the address.
Oh, that's nice. Well, I can tell people to put fake emails then, if they ask.
Take some armor.
Get over here and heal up.
Oh, I'm pretty sure they do verify your email though. Put a real one of those, but
Shields holding.
Огонь по готовности!
Doing better. Rolling to me.
yeah, you need a real email. But other than that, the address can be fake.
Fuck. Wow, we won.
Behind.
Good job.
Yeah, wasn't really me, but
Yeah, good job to you and your team.
actually, it wasn't me. I'm support, so it kind of was me, huh? What's most important on a team? Mystique.
You're one.
Sucks you can't check the heals of the other players, you know? Yeah, but this team is pretty atrocious.
This place is to my liking.
Do you don't play this game, right?
No.
That's good. You should keep it that way. This game is absolute cancer.
4, 3, 2, 1. Round 3. Capture the objective.
You know when you realize like all games are bad, but you're used to one, so you're just like, yeah, I'll just play this one, even though they're all pretty much cancer.
I don't know, I realized that a long time ago and just kind of stopped playing games.
Shields taken down.
Yeah, it's an utter waste of time.
Yeah, I used to be real into them, just kind of slowly got out of them.
Armoring you up.
The objective is now
Get in there. I'll take it in. Giving you a little. Best offense is good defense. Take some armor. Step off. Pull it quick.
Fuck, I need heals.
Much better. Feel better soon. Best offense is good defense.
Best offense is a good defense.
I did used to play this one game. It was a indie stickman combat game. And man, that used to be really fun until the developer totally messed it up by nerfing the guns. But basically, me and my friend would just play offense really hardcore, and we'd always win. Defense was almost non-existent, although it was nice when it was there.
Good as new.
surrender to my will.
My barrier can't take much more.
Fuck.
Reality bends.
Dude, you're gonna have to repeat that. It was really intense when you said. So you said you used to play a game that what?
It was like a stickman 2D combat game, and me and my friends constantly played offense, and we'd always win.
I
So
love that
deep-
game. Is that the one with the AK-47s and shit?
I mean, it's got all kinds of guns. Boring,
was-
man.
Was it like a Flash 2D side scroller sort of thing, or a top down? I mean.
No, it wasn't top down. No, it was actually a side scroller.
Feel better soon.
Yeah, I don't know. I don't think I've played it, but I played another stick game.
Giving you a little extra. Armoring you up. I have located
Oh shit.
Back this up.
Огонь по готовности!
Wow. I can't believe they took us out so close to fucking overtime.
Back to the top. My shield's up.
Oh shit. Our team's mostly dead.
Group up with me. Feel better soon. My barrier's about to go.
Behind you.
Take some armor. Teleporter online. Rally to me!
Surrender to my will.
Reality bends to my will. Policy creep.
Okay, I'm pretty sure I already registered and made my account, but I can't figure out where to log in or anything. It's just asking me to tell them my address again. Weird.
I am on fire.
Oh, holy shit. Did we win already? Damn. Fucking A, man. What a game. We won. So you good with the account?
Not sure. I thought I made it, but
Oh, hey guys, I'm back.
Hey, how you doing?
hey.
How you doing? Oh, hey, you my dude. I think
Yeah,
we've talked
what's
before.
up?
I know you, dude.
What?
I think I know you from like a conversation we had before, like something
Yeah.
about like integrals a while
Maybe.
back.
I'm not even. I wasn't even sure if that was you, but yeah, I think we.
Yeah, because I remember you from that like conversation.
I'm
So,
gonna
yeah.
I'm gonna grab some water and use the bathroom. I'll be right back.
All right, buddy. Sure. All right. So how you doing, man? I think we were talking about like Riemann sums, or I don't know. Just the general definition of integrals or something like that.
Yeah, I think I was asking about integrals. I'm pretty well past that now.
Yeah, man. You're in chemistry right now?
Yeah, no, I'm actually homeschooled and I'm just teaching myself everything, but I'm like
Okay.
way ahead.
That's pretty cool. Okay. Yeah, man. I don't know. University or like college, I don't know. It just doesn't work for some people. You can just do it independently.
Yeah, I've been having a lot of success doing that.
That's awesome, man. That's good to hear. I don't know, man. Like either fortunately or unfortunately for me, I just have to stick to college or university. You know.
Yeah, it's not right for some people, but it is right for others.
Yeah. Yeah, because some people say that. Yeah, what do you want? What do you want like lectures for? Or why do you attend lectures? I don't know. It just makes stuff easier for me, you know.
hmm
because I can't do it that well on my own. But if there's like a teacher or like some kind of instructor, I learn it a lot better.
Right now I'm trying to get my Mathematica account working.
Alrighty, guys.
All right.
Let's see.
Oh, I think I got it. Heck yeah.
Nice.
Fuck, where's that other? Some people are saying they can't make it, but there are 2 sessions. Tomorrow's 5 p.m. Central, 8 p.m. EST.
I see. Are you gonna be covering the same material or like?
Yeah, exact same. Just because there's so many time zones, and I don't want to shortchange people in Europe.
Oh, okay. Okay. I'll rather stick to like tonight's sessions.
Man, I would have totally been able to make tomorrow's a lot better.
Hello there.
Oh, hey, what's up?
Nothing much.
Hey, man. We're about to get started. Some people
Yeah.
are saying they can't make it, but there's another session tomorrow with the exact same material. So
Okay, I'll leave then.
Oh, welcome back.
well, welcome, man.
All right,
So,
I unmuted Twitch and got to hear that hilarious joke twice.
Yeah, if you should probably mute Twitch, so you don't
Yeah.
hear me twice.
Mhm.
okay.
Yeah, we tried Blackboard collaboration. We tried a bunch of screen sharing, Google Hangout. Discord would have worked. I mean, it still could work if there's less than 10 people, but Twitch seems to be the best one.
The
Hangouts
best way
was,
of going about it.
yeah, Hangouts was freezing. I mean, it had better quality, but it's just freezing for Radical.
Okay.
Yeah, I don't know what was up with that, but
We could always give it another shot another time, but not during the actual session. I might just try some testing. Could be my computer, maybe. Not sure. Hey, how's it going, man?
Good.
Got a full house
What about
tonight,
you?
huh? Not doing too bad. Just was fooling around with the screen sharing software. I was telling these guys we settled on Twitch.
Yeah, it's fine. It's like a 3-second delay, so not that bad.
Why don't we go around and talk about each person's experience with programming? So start from the top. Blend, are you there?
Oh yeah.
You want to tell us your experience?
Well, I'd say the most complicated thing I've ever done is I made like case-sensitive rock paper scissors that insulted you if you didn't do the cases right. So that's the extent of my experience
Okay.
in C#.
Oh, that's a nice language.
Is it my turn?
Yeah, I guess.
I'm just a petty beginner, hoping to learn the ways of the masters.
dude, hell yeah.
All right. Well, then you'll be perfect here. Fit in perfect. Most people here don't have programming knowledge. David?
Yeah, my experience is basically non-existent, so
Perfect. That's what this course is really for. But
Yeah.
it's since most people don't know Mathematica, even some people that have good programming language can probably learn a thing or two. I know about 20 languages. I've been coding since I was 10, and when I actually was introduced to Mathematica, I thought, okay, well, it's all about math. Same thing with Maple and MATLAB, same story. But it's actually a really cool and powerful language, and I chose it specifically because you can do a lot without knowing a lot, and it makes you feel sort of empowered as a programmer. Radical, how about you?
Yeah, so I guess I started programming since 9th grade on C++, and just got interested in game development a little bit, worked a bit towards Unity, started doing work on Unity, and eventually just got interested into the math aspects of things. So I worked with MATLAB a little bit as well. So that's the closest thing I've got to Mathematica, I guess.
Very cool.
That's it.
Welcome, Shabir. Do you have mic?
Yeah, I do, but there's a lot of echo, so I'd prefer staying muted.
So
No, you're all good.
So just if you want to mute Twitch,
Yeah, you
that'll
can
probably
pretty
help.
bad. If I want to what? Oh no, it's not a Twitch thing. It's just my headphones. Like if someone talks on Discord, you can like hear it. There's a lot of replay. I don't know why. I can't get it fixed.
Oh, all right. Well, we're going around saying what each person's experience with programming is. So if you wanna, you're actually next in line. So if you wanna just say a brief thing about your programming.
Sure. I started like this beginner's course about a month ago or something online for free. I think it was called something camp. It's probably I have it bookmarked.
Boot camp, you mean?
Yeah, that one.
Yeah.
I started off with that one, but I guess I kind of lost motivation because it seemed pretty random. It didn't seem like I was actually learning anything. It just told me to do X, and I would do X, and then that'd be like the end of it. And I don't feel like I would have like been able to apply that thing.
It's just
the
a
knowledge,
bunch of
I guess.
exercises.
Yeah, exactly. So that I guess I would. That's about it. I can't remember much.
I can feel you for that. Yeah, that's the main problem with teaching mathematics and programming, because these professors, I mean, it's not always the professors themselves, but these curriculums tend to be, you want to calculate this, calculate that, and it just like shows you sort of what the framework or the scaffolding looks like, and then you just copy it, and it's like, all right, well, I didn't even want to make that. So like, tell me something I can do that I want to do, right?
Yeah, exactly. Like I didn't feel like I could reapply that. Yeah, exactly.
All right, great. How about you, Yum?
I've been programming for a couple years now, and mostly just writing scripts and tools in Python, but recently got a job as a web developer and working with JavaScript and PHP a whole lot, so I've got quite a bit of experience, and I'm mostly just here to learn Wolfram.
Cool. Yeah, I actually have a pretty strong background in web development. That's what I used to do to make money to get started, and I worked at Amazon recently, and I was a senior web developer. So definitely the lucrative end of the, I guess the industry. Did someone just join? Oh, Frank. Hey,
Yeah.
Frank, how's it going, man? We're
Hi, what's up?
We're just doing intros to what our programming experience has been. Everyone here has spoken, so if you want to just give a little blurb about your programming experience. If you don't, that's fine too. It's up to you.
I haven't done much programming, but in high school I took a CNC class and computer science class, but I'm a math major, so that's why I just want to learn Mathematica. So yeah.
All right. Well, we won't be covering much math stuff, but learning the language will definitely help you use most of the math functions within it. Okay, so it's 11:02, so I guess we can get started. Should we be waiting for anyone? What do you guys think?
And there's always tomorrow's session, right?
Yeah, that's true. Okay, so let's get started with the history of programming, a little philosophy on why programming is so powerful and what it means. So first of all, when people think about a computer, they think about circuits and like this kind of magic going on inside a computer, but the origins of computer go back to what Alan Turing came up with, this definition called the Turing machine. He basically was able to describe what a computer could do, and anything that was a Turing machine was able to compute just as much as any other Turing machine. So the Turing machine, basically, it was his definition, but he himself, back in 1942-ish, around there when World War II was waging, the Germans had this machine called the Enigma machine. I'm sure you guys might have heard of it. And they would just spin a bunch of rotors, right? Each one would get a random configuration. They'd mark what the spin was around. They'd have a little sort of arrow, and and that would be the key. And at first we have mathematicians who are cryptanalysis, and they'd sort of try to find holes, but beyond a certain point, there was just so much randomness, so many rotors with so many possibilities that it was impossible for a human to really check that. So these computers were the size of an entire room, and like a small bedroom, and they would have huge tape drives. So nowadays, the only thing you have in a computer is that's moving might be the hard drive, right? The spinning platter. But even now we have SSDs, flash memory. So there's really nothing moving except electrons in a modern computer. But you go back then, and you have the spinning tape drives, and you have, instead of transistors, you have a bunch of bare wires sort of all connected and daisy chained. But it's still the same principle. The principle was that, and how Alan Turing described it, is a computer is anything that a computer can do anything a person can do. So there's this famous idea by this philosopher Searle, and it's called the Chinese room thought experiment. It's like if you put a person in a room, right? You gave them a Chinese to English dictionary. It's a huge manual. It might be 2,000 pages. You give them that. You lock the door, and people pass them Chinese underneath the door. That person just takes the Chinese they received. They don't know Chinese at all. They're English. They go in the book. They look up the symbols. They write down on another piece of paper what the translation is, and then they put it back under the door. Now, that system, right? Just the room itself, yeah, it contains a person in it, but that room itself is like a computer. It wouldn't matter what's inside a computer. It's just the fact that a computer is equivalent to a person manipulating information. Anything a person can do with a pen and a piece of paper, a computer can do, and vice versa. So the question is then, well, if we have such sophisticated computers with all these colors coming out of the screen, able to print things and put out sound, how does that really go from a person in a room with a piece of paper to something like that? Is it really the same thing? And the answer is yes. The thing is, the stuff that programmers do these days, right? We are not going to be manipulating bits by bits that get painted onto a screen. We have higher level libraries. We have a graphics card and drivers. We have an OS. When you drag a window around the screen, right, the OS takes care of repainting, telling the graphics card where to put things. But back then, like let's say go back to the days of when Asteroids came out. It was just a CRT monitor with a bunch of green lines, and it was either green or black every pixel. It was either 0 or 1, green or black, and the actual pixel on the screen corresponded to a place in memory on that computer. So if you had a 100 by 100 screen, then you had a 100 by 100 memory slots, which is just 10,000, right? So you basically were able to just modify memory, and it would immediately turn into output. So a computer, right, is manipulating information, but it really is nothing without the peripherals. Without a screen, without a printer, without speakers and audio card, without any of this stuff, all it can do is manipulate information. It can't put it back out there. So in the same vein, a person with a piece of paper could run Windows. They could run Windows OS. They could drag windows around, but you tell them that the tiles on the floor are the pixels, and they'd color them with magic marker, and it'd take a light year, but they'd get it done. Any questions about this idea?
No, not from me.
Not really.
No, nothing much. So the thing that you were trying to imply with the Chinese room was that like the computer doesn't necessarily have to know Chinese.
Right.
And it just could be following instructions and mimicking things.
So that's that room experiment. You're right. You're absolutely right. It was actually about consciousness, and the question was, is what's inside the room conscious? Like, it's a process. The person doesn't know Chinese. He doesn't understand it, and yet he can translate it, or the room can translate it rather. What's in the room doesn't understand it, doesn't know Chinese, but still the room itself is able to do it. So the question is, if you have an intelligence, right, a computer that is able to do so many different things because of the programs on it, if it has all these competencies, is it conscious? I don't know the answer, but it's definitely a computer. If a person has rocks and they move the rocks around in a certain pattern, right? That will be. Well, I don't have to actually paste that. You guys are all watching the screen. So there's this comic XKCD, and it's like if you had a guy in a desert. He has infinite space. He has infinite time. You know, you could call him God, right, if you want to. But he just has rocks, and he's, you know, manipulating the rocks based on some rules. He's running a computer, you know? It's the time scale that fucks with people. They think, well, computers do mad. No, it's just faster. That's it. The electrons are, you know, you can make a computer out of running water. Instead, our computers run on electrons moving around. So yeah, that's. I hope that places computing in the right frame of mind for you guys. So what we're concerned with, though, is we're concerned not with manipulating tiny little things. We're concerned about programming practically, and programming practically involves outsourcing a lot of the work. So, sorry, let me get this on the right side of the screen. So outsourcing the work involves using libraries, and the reason I like Mathematica is Mathematica has this huge library, right? So it has functions to handle tons of things, images, sounds, pulling information from web pages, like doing a Google search and grabbing the first result, taking data and doing statistical analysis. So of course all these things can be done bare bones, but for a beginner it's nice to just be able to outsource. And even for an expert like myself, if I don't plan on, you know, putting it out there, making it faster and optimizing the hell out of it, I just want to get stuff done, this might be the language to do it if it provides nice, concise way to do it. The bigger your libraries are, the more they do, the smaller your programs are, because you call out to the libraries. All right, so any questions about that? All right, so the first thing we're going to do is we're going to get introduced to the notebook interface. So does everyone have their Mathematica online or desktop software open?
Yes.
Yep.
I do.
Yep.
All right, and I don't know if anyone just recently joined, but you might want to mute Twitch if you're on the voice chat. Okay, so first thing we're going to do is we're going to talk about just simple mathematical operators. So pretty much every programming language allows for the standard mathematical operators, plus, minus, exponentiation, and we're going to learn a few shortcuts. So for example, if we want to do 5 plus 10, you hit Shift Enter, and that will execute the current statement. So this is a notebook interface. There's a couple different notebook interfaces with different languages, like Python has Jupyter. There's also Sage, and there's a bunch of others. Notebooks have gotten popular lately because the normal programming flow would be you open an IDE and you compile, you build, and then you compile, and then you might run it on the command line. With a notebook, it's a little more casual. You know, just you can fool around. Nothing has to be saved. So anyways, you hit Shift Enter, and that'll execute a statement. You can go back and you can edit it again and press Shift Enter and get another output. Now, if I want to use the value from some previous line, I can do that with the percent sign. So for example, I do percent, that gives me my last value, 45. So if everyone could just write a little math equation or math sum or some kind of value, and then execute it, and then just execute a percent sign, you see last value. Now if we want to go 2 values back, right? So we do %2, which really isn't going to do anything here since that's just going to be 45 again. But let me adjust this and you'll see what I mean. Oops. So if I do %2, okay, well, it's because I'm editing the values. It gets a little hairy. But essentially, percent will go 1 result back. %2 will go 2 results back. %3 will go 3. And you could even do it as %% or %%%. So let me see if I can just demonstrate that real quick. So if I do 1 plus 2, 2 plus 3, 3 plus 4, 4 plus 5, right? And then I do %, that'll go 2 results back, so it should be 5. Or rather, sorry, it should be 7. That's 2 results. If I do % and then a number, so like 51, you see how there's a number next to each line? That'll give me that line. It'll give me the value. So you don't need to always assign a variable when you're working in Mathematica. You can reference a previous computation So call these what you will when you shift enter and execute something. It's computation, a calculation. They're both the same. It's just something that was code and became evaluated, and you transformed information. You went from input to output, and then you can further use that output. That's all a program is. Program is just taking some input and successively transforming it until you get the desired result. And that may involve all kinds of things, and then that ultimate output may be in the form of an image, a file, or something on the screen, or whatever it may be. But that's essentially what a program's going to do. Okay, so let's talk about let's talk about input, right? Since we're talking about that now, how can we get input? So biggest thing, the most exciting thing about a program is the ability to interact with the user. So if you can't interact with a user, what the fuck's the point of a program? I mean, programs could be nice and shortcut a lot of work that we would have to do manually, but I think the nicest thing is having games, having things that you can adjust, like sliders, and ask user for input, and sort of interact. So let's do a little example with that. Any questions about this percent sign stuff? I'm just gonna pop it up real quick if I can. It's right here.
Oh, just one thing. How can you like clear all these references? Let's say we just want to get rid of these I don't know, previous references to, like, I don't know, the 50th output or whatever. We just want to get rid of all of them. Do we just like use the clear all command, or?
So you can just highlight the right side of them. You see, you can actually fold things in here. If you double click, you can fold the result. And if you click the right side, it comes back. You can fold it in, fold it out. And then if you hit delete, it'll just go away. Or you can highlight multiple, hit delete, they go away. If you want to talk about the number, I'm not sure. I think it'll just keep continuing with that ID. And I think even if we can reference older ones, even though we cleared them, which is kind of funny. If you totally just want to go back to ID 1, which you shouldn't, because it's not really, unless you have OCD, it shouldn't really affect the code. But I think you quit the kernel. Quitting the kernel will sort of resets all variables, resets everything, and then if you ran something again, I think it should, yeah, there you go, 1, you see? So
I see.
you go to quit kernel. I'm not sure how that works with the online version, but on this one, you can just quit the kernel, yeah. Any other questions about this part? I pasted the parentheses or the percent sign doc in the chat in case you need it later. Okay, so let's go on to input. So there's a function, right? Well, let's get accustomed to the docs. So if you highlight some function, right? So I know what the function is already. It's input string. But let's say you have some function and you forgot what it does, but you sort of remember the name. You hit F1, and that'll pop up documentation for it. And you can even search for other things. Now you can also, lagging a little bit, you can also just use the online docs and just search for it. And this is probably more helpful when you're not sure what it is. So if I want to like get input, you know, you find this, and then you might click this, and then this isn't exactly what you want, but there could be related things there. So here, requesting input, perfect. That's exactly what we want. So Wolfram's docs usually have sort of like categorical sections, like this one's all about requesting input. So what we're gonna do is we're gonna use input string. So let me talk about what functions are first. So basically, a function is in most languages, right? In fact, when it comes down to it, at the lowest level, what these programming language transform stuff into is they're just using functions. So whatever input you put in, a lot of functions gets called. You know, some things get stored, some things get more functions applied, and that's really a function is how you call out to some more sophisticated behavior to, you know, act on your input to get things from the computer, and they'll be the basis for everything we'll be doing. So a function could be as simple as the input string we'll get back to, but let's just learn how to define a function first. So if I want to multiply something by 2, right? Of course, if I know it's 5, I can just type 5 times 2. But what if I want to repeat the same operation over and over and over again? I wouldn't want to keep, writing times 2. I'd want to sort of, create a macro, create some kind of symbol that represents that, especially if it was more of a complex operation. Like, let's say I want to take some number and, I want to multiply it by 2 and then square it and add 5, right? It just so happens that Mathematica handles variables perfectly fine when they're not set, right? So in every programming language, right, except for very pedantic ones that are what are called functional languages, so don't worry about those, but in almost every programming language you have the idea of a variable. So just as we did percent sign 1, right, to get the value or the output of calculation 1, we can actually assign a name to that calculation. So we can do, x equals 5 plus 3. Just put a colon at the end and you execute it, and now watch. If I put x, I get 8, right? So x has been assigned. All right, now watch. We execute this statement, x squared, or x times 2 squared plus 5, and we'll get the actual value, because x now has a value. So it's not symbolically executing more. This may be a little confusing, but it's really not important right now. I just want to show you what functions are, and that kind of necessitates knowing what a variable is. So, variables are like cubby holes. You can perform some operations, put some value in a cubby hole, and then get it later, because you may not need it right away. You may need the you may need the values of a couple cubby holes together, and you sort of, when you program, you want to break up what you're doing into successive steps. You don't want everything on one line without any variables. It'd just be a fucking mess. You could do it, but it'd be disgusting and you wouldn't even know what's what. So variables are really important for being concise and being organized. Okay, so let's write a simple function. Let's actually use what we have here to write a function. We'll say we want to perform this on x, right, and get a value back. So this is how you write a function. X is the name I'm giving to the variable. F is the function name. So I'm actually going to make this longer so you guys can see. This is the function name. This is my variable name, right? And these are verbose, and they don't need to be, but for sake of explanation, I'm doing that. And then we put what we want the value equal. And of course, yes, the syntax is a little hairy, and there is more compact syntax for defining functions. But I don't want to confuse you guys and give you all the different ways to skin a cat. So just bear with this syntax that may be a little, strange looking, and just copy it for now. So we want to do x times 2 squared plus 5, right?
Okay, so you just use those parentheses as when the function definition gets longer than a single line, right?
Exactly. So in fact, we could break up this function because we can do it on. So let's say we want to assign partial.
Or like a piecewise function. Maybe.
Well, not really. I'm just talking about breaking it up. So you do partial sum equals. Or let's say partial val equals that, right? And then we'll do partial val equals partial val plus 5. So as you can see here, we still have it up there. We first set our partial value to x times 2 squared. And I'm sorry I'm using math for this. I know this isn't supposed to be about math. It's just a simple way to show that something can be done. We're going to strive to be away from math as much as possible in this class. I just want to show that if we want to do some operation, we can do it in a function and we can split it up in multiple lines. And then essentially the last thing that we're going to want to do is return the value. So a function basically needs to return a value. Not always, but in this case, we want to return partial val. So here, let's shift enter, right? And then I'm going to call that function called function name on, what did we call it before? We called it on x was 8, right? Or sorry, this was supposed to be not x, it's supposed to be my variable name. Sorry about that. Okay, so we're going to call the function on 8, and we should get 261, which is what we get. Okay. Any questions? I hope the names weren't too confusing. If we can just set this to F and this to, like, you know, V, right?
Okay, and the partial value variable isn't defined outside of the function, right?
It's not defined. It's just a, you know, it's just a cubbyhole. And
Okay.
yeah, there are scopes in Mathematica, but I don't want to confuse the beginners. So just know that if we want to store some temporary value, so we can do our calculation in multiple steps, we can do that. So this could have just been this. Watch, this whole function could have been return, you know, v times 2 squared plus 5, right? And that would have done exactly the same thing, but you could split up any large calculation as much as you want to make it more readable, to make it just easier to write. You know, however you want to do it, you can. Okay, so a function basically takes inputs and returns outputs. It transforms information. Could be a number, could be a file, an image, a string, could be anything. A function will just take some data and operate on it and return something different. Okay. So let's talk about here. We define our own function, but the amazing thing about programming languages, the libraries, is that many of them have libraries that are thousands and thousands of functions that you'll probably never even use all the functions in your entire life if you use that same programming language. And this is called what's called an application programming interface, API. Basically, the idea is that if you're writing an application, why should you invent the wheel twice? Why not use what's already been written and does the job well? So that's why libraries are so important. And one of the first mistakes that I made as a programmer when I was a novice was thinking that if I write it, I can do better. You know, they might have fucked up the way they wrote it, or, you know, they didn't do it as optimized as I could. So I wanted to optimize everything. I wanted to run fast. But the truth is that we have processors and computers so fast these days, and most of the libraries are written pretty well, at least, you know, the most popular languages. Like Mathematica is actually written in C++, most of these library functions, which is a very fast language. So don't get into the pitfall, the trap of thinking that it's bad to use APIs. It's actually good. It makes your program smaller. It outsources most of the dirty, you know, heavy lifting, and lets you be elegant, which is what, you know, it's aesthetic. Who doesn't like aesthetic, right? I want my program small and readable, and, you know, let fucking Wolfram code up the complex shit. Let him sit in a basement for fucking 10 days straight writing shit. So let's call a function of Wolfram's now. Let's call a function that we didn't write, and that's called input string. So functions can be what's called overloaded. So overloaded just simply means that a function has multiple ways to call it. It could take one argument, or it could take two. So, you know, it could take one variable, or it could take 2 or 3, or it could have all different types of ways to call it. And I'm not going to talk right now about how to do that, how to implement overloading in your own functions that you write, but just know, as you can see here, there's a couple ways. We can just call input string without arguments, right? Let's do that. And it should ask us for some input. There you go. Enter a string. Okay, so let's see. Boom. That was the return value of that function. Everyone at the same stage. Anyone get confused yet? Anyone need anything explained or have trouble executing the code? I want everyone to be executing this in their own notebook.
So the input string is just used for getting strings as input, and the regular input command, that's for numbers. Is that how it works, or?
So the regular input command takes in code. Like literally, it'll take in a string of code. A lot of languages have what's called reflection. That means that you can have the user input actual code, and then you can run that through the interpreter. But that's really like higher level stuff, and I don't think it's wise to get too much into that right now. Let's just deal with strings right now. Someone else say something? Okay, so everyone executed input string and got a string back. All right.
Yep.
Let's try to run another function on top of this, so I can show you what composition is. So composition, right, is executing one function after another. It's like, call this and then call that with the input from that, and so on and so forth. So simple example is if we want to turn this string into uppercase, right? So I don't remember every fucking name from every programming language. They all have different names for functions. So I'm going to look it up real quick. Hope you forgive me. So we should have string upper. Let's see. String operations. There we go. I believe it's okay. 2 uppercase. There you go. So we're gonna put 2 uppercase, and we're gonna put these square brackets around. The square brackets are basically what you use to call functions, as we did here. So you should always have nested pairs. Should be one closing for every opening. All right. So if we do that, I enter another string. We should get whatever you entered, but uppercase. Right. Now we can take this a step further. Even is we can run some other thing on it. Like let's say, let's see, what can we run? Something interesting. Yeah, we could use characters. It'll break a string into a list of characters. So that'll give us a good intro to talk about types once we do this. But let's use variables a little bit first so we can get used to them. So I'm gonna just set x equal to input string. Okay. Actually, I'm gonna try to give better names so for explanatory purposes. I'm gonna call it my string. Okay. I run that. All right. This is my input. Right. Now you see you didn't get anything back because I put a colon at the end. The colon suppresses the output. This is just a notebook style thing. So don't be too concerned. You could have wrote it like this, same exact thing. This is my input, and you'll actually see the value of that. That's all the colon does. It suppresses the output. Okay, so if I run my string, right, just to check the value, so everything's fine, right? So now I can do 2 uppercase on it. Right. And what I could do here is I could even set it back to my string, right? I can just so it's sort of, this is an idea in programming that it is a way to be a good programmer, is to do things in multiple steps, so it's easy to follow. You might even put comments. We'll talk about comments in another seminar. But here we go. So execute that, and if I check my string, sure enough, it did get set. The variable holds this string. This is my input. Okay. Now let's try some other functions. Here's a fun one. Given a string, it'll give a list of the characters. So we'll call characters on my string. Shift enter. This is my input. All right. Everyone following along? Any questions?
Oh, yep.
Okay. I hope you're not all intimidated and you really don't have questions. No questions, right? Okay.
I kind of had one, although it's kind of unrelated to exactly what you're doing.
That's fine.
Kind of goes back to when you were defining functions. I was kind of curious about why you had an underscore after the input parameter name.
So I'll show you real quick, but in fact, was it what's his name? Radical asked that earlier, and um, let me show you something real quick. And we're not going to dive into it, but just so you, just so I can answer your questions. So there's something called patterns, and the idea is that when you specify the arguments to your function that your function can take, right? You specify names for what you want, this stuff to get set to, so you can, act on it, calculate with it. But you can actually do really, really crazy stuff with parameters. For example, I'll show you real quick, but this is like higher level, so we're not going to go into it this seminar. But if I put like v underscore underscore, that's actually a sequence. So let's say I did that, right? And I just, let's say, return v, right? I don't do anything to it. I just return it back. And then I call, let's say 2, 3, 4, 5. Hold on. What happened? I need to reset the kernel. Give me a sec. Not sure. Should it be that? Or... my computer's jamming. This. Well, so there's some complications. That's why I didn't want to talk about it right now. But this is essentially what'll happen. So if you want to like take in certain thing, like you don't know how many arguments your function's gonna get, right? Let's say you have a function that, let's say, wants to multiply as many numbers as you give it. Let's say the result of this, you want it to be 2 times 3 times 4 times 5. You could do, right? You could do v x y, right, z, and then do, v times x times y. But what if, you want to make it generic? So if I passed in 5 or 6 or 7 numbers, it handled it just as well. And you don't want to have to copy and paste this definition and write all these 7 variable names or whatever. Then you could use this pattern of a sequence, and you'll essentially just do something like this. So, and you get 120. But this is complex shit. All I want to say is there's a reason that it's 1 underscore and there's an underscore there. It's that there's a lot of power that we're not really gonna go into right now.
Yeah, right. I see that. Thank you.
Of course. Okay, so we got the characters. Let's go back to our other page, and we could even combine them back. So let's just say my characters, right? And I reset the kernel. So let me see. I reset the kernel and all the variables got reset. So let's do that, and then we're gonna combine them back, which is where was it? Am I crazy, or wasn't there a function to combine the characters back? Oh, I think it was down here. String join. There we go. So functions are the basic kind of elements of programming, and values are what functions act on. Values are what functions return, and values can be numbers, can be images, text, data, anything, sounds even. So let me think about where we're gonna head next. Sorry. All right, so let's talk about logic. All right, acting on variables to do different things. Okay, since we have input from the user, right? We may want to do things based on that input. Here we're transforming it, which is great. But let's say we want to do some tests. Like if the person enters fuck, like, pop up a message saying don't curse. And if they enter anything else, we'll say, okay, thanks for being polite, right? So we're going to need what's called logical operations. And those are basically known as conditionals. And conditionals are pretty, the interesting thing about mathematical conditionals is that they're functions. Just like the other functions we called right here, an if statement is a function. It takes the condition, and then it takes the value that should be returned if the condition is true, and then it takes the value that should be returned if the condition is false. So let's just write a simple one real quick. So the equality operator, let me get operators up real quick if I can. Okay, so this is a good page. I'm going to link it in the Discord. This is a good page to take a look at if you're wondering what conditionals, but most of them are just the basic mathematical kind of things. And of course, if you don't want to do mathematical conditions, like you're looking at a string, well, ultimately you could just compare to like true or false. So you'll still want something like equality. So for example, we want to check if a person is entering fuck, right, in their string. So we're going to basically, we have to use some string operations. Let's go back to our string page. Forgive me if I'm a little disorganized. Let me just hit F1 here. Okay. So, actually, I'll just type in string here. Okay, so you guys should get used to this searching around the documentation. It may seem like some programmers are wizards and they know all the functions and they just like write it without looking at docs. 99% of programmers are going to look at documentation. 90% of mathematicians are going to open up a book and look at certain things. Like there's no way to remember everything, especially if you end up learning multiple programming languages. It's actually fine to look at docs, and good IDEs will help, like that you can highlight something and hit F1. There's actually a bunch more ways to get help and to like look at docs and things, but I don't know all the shortcuts. So I'm just telling you what I know right now, which is the F1 and then the online docs, which are pretty good for the most part. Okay, so we're gonna want to use string contains Q. Okay. So with Mathematica, most functions that are sort of like a test, like some kind of, they'll return like a true or false, those functions end in Q for the most part. So like there's a function even Q, right? Which is basically just tests whether whatever you pass to it is true or is even or odd. So for example, even Q4 is true, and even Q3 would be false. But on the other hand, odd Q3 would be true. So we can write an if statement, like if odd Q3 equals true, then output odd. Otherwise, output the string even. Right? And you see our if statement is actually a function with 3 arguments. That's an if statement. It's a function. And you can make it cleaner if you have multiple things that you're doing. But right now, I would just stick to small things just so you don't get too confused. We'll definitely go into how to make code a little bit nicer looking in future seminars. So because it's a function, the if statement, we can actually use it as a value. So for example, I could do 2 lowercase on this, right? And white space does not matter. I didn't mention this earlier, but you could add as many enters as you want, as many spaces, tabs. White space is irrelevant in this language unless it's in a string like that. Well, of course that makes sense, right? Because space is a character. But the program language itself does not care about white space unless it's like inside of strings as values and whatnot. So if we run this, boom. So the result, our if we called the if function with a conditional, first argument, and we got odd because it was true, right? Odd Q3 was true, so true equals true. It gave this instead of the other one, and then we ran 2 lowercase on the output of that. All right. So I'm gonna clear this. Well, actually, I'll leave this up, and I have an exercise for you guys. I want you to you don't have to define a function, but I want you to get input from the user using input string, right? This right here. And you could save it to a variable if you want, you don't have to, but I want you to get input from the user, check if it contains, using string contains Q, check if it contains the string fuck, and then if it does, return profanity detected, otherwise return clean. It doesn't have to be that exact thing, but just return something specific if it has the word fuck, otherwise don't. And I want you to run it multiple times, entering fuck and entering something without it, and see the result, see the dynamicism. Okay? And don't worry about what it says patterns here. It's just put a string as the second argument. Just put literally something like this. String contains Q, whatever you have on the left side, whatever that value is going to be, and then something like that. That's going to be what it looks like. Okay, so I'm going to give you guys a couple minutes, and then we'll go through the correct result, correct code. I'll leave this up in case you want to take a look at it. I'm going to just delete the irrelevant parts. You can choose to write as a function, but you don't need to. You can just put it in a input box and execute it multiple times or whatnot. It's so quiet. Is everyone still here?
Yeah.
Feels like,
Yeah, I'm here.
No.
I haven't really taught classes before, so the crickets kill me. It's like, do they hate what I'm doing?
No,
No,
man,
I'm
you're
paying
doing
attention. I'm writing the code now.
Okay, yeah, just focus on the code then. If anyone has problems, feel free to ask for help. I should mention the thing about if statements is that if the first part, the conditional, already is a true or false value, you can just do something like here. I'll show you. Here we didn't need to actually do equals true. We could just put if odd Q3, and we would get the same result. So you can do that with string contains Q2, just as long as your what's in your conditional is a true or false, then if will handle it. You can only have true or false in an if. Otherwise, it doesn't make sense. I mean, if 3, what does that mean, right? So it has to be a true or false value.
Okay, got mine, tested it.
Alright, nice. You tested multiple times?
Mm-hmm.
Working well?
Yep.
Perfect. How about everyone else?
So yeah, I'm coming up with like blank results here for some reason.
You wanna paste your code
Yeah,
and
I'll-
I'll take a. You can paste it in the main. It's fine.
Okay.
Or you could PM me if you're embarrassed. So I don't care.
No, it's fine. I'll just post it in general here.
Okay. Oh, was I posting all that stuff in announcements? Fuck. I'll fix it later.
No, sorry.
Um,
So I first off saved the
I know why it's not working.
but-
You forgot the colon at the first line. You need a
Oh,
colon
okay.
after that line, yeah.
Okay.
Otherwise, it looks perfect. I think, yeah. Let me know if you guys could just say something or in chat if you've got it or you're having trouble. So.
I mean, I'm still having trouble with this. So yeah, I put a semicolon after the variable declaration, right?
Mhm.
A equals input string, and I don't know. That didn't still solve the problem. It just when I just run it, and I just type in something like I don't know, hi. It just says assuming the string uses suppressed output instead.
Okay. It's because you have a colon at the end, so it's using suppressed output. So
Oh, okay.
you needed a colon over here with that a equals, because essentially if you just have it like with no colon, it's like it's all one line. Like, because remember, white space doesn't matter in this language. In fact, in most languages, white space is irrelevant. In C++, C, you have to have colons. Python's weird like that, but you do need a colon, because otherwise it literally, see if I stretch it out, that's what you had before. The white space doesn't matter. It's like doing this does nothing. You have to have the colon. Okay.
I see.
So now let's see. Enter a string. Fuck you. No profanity. And testing. 1, 2, 3. Thanks for being polite. So it looks like you did a good job, man. Perfect. Everyone else got it yet, or having trouble?
I got it.
Nice.
Yeah, I got it too.
Nice. That was Hume, right?
No, that was someone else.
That was me.
No, that was.
David and Hume have similar voices. Seriously, you guys do. Okay, so I guess we can continue then, if no one's voicing any concerns. It's getting close to an hour, and I thought I was gonna run over time, but I think we've covered a decent amount, and we haven't. So the last thing I'm gonna go over is types. So we're gonna talk about the different types. Here we've seen a string type, and string type, is kind of common sense what it does. It holds a bunch of character data, but a string can be a binary string. Like a file can actually be a string. I know, crazy, right? But instead of ACI characters like A through Z, it'll contain different characters. So if you've ever opened a file in a text editor, you'll see what a string might look like. Like if I open this in well, Notepad++ will probably handle it, but not so well as you can see. So you can have a file and you take it as a string, even pull off the first character, and that's the data of the file. So you can process non-English and non-written language stuff using a string. But the other thing we're going to talk about is the other types. So we saw numbers as a type before, right? Just a straight numerical value That is a numerical type. We have strings, but we also have a list, right? So the point of a list is if I wanted to hold a lot of different pieces of data, for example, I took an input string in A, right? And I, got another input string and another. I may want to do something with all of them. And having them all as different variables, right? I set B to something, I set C to something, I had all my variables, and then I wanted to do the same thing to all of them. Then I'd have to do something A, oops, I did not mean to execute that, sorry, it's a reflex. Do something A, and then I'd have to do something B, and it'd get tedious, especially if I had a lot of different variables. So if you want to do the same thing to a lot of elements, a lot of variables, a lot of the same, a lot of different values, you'll want what's called a list. So the list syntax is pretty simple. This is how we declare a list. You use these curly brackets, and you'll just put one for the open and another for the closure. And it's a list is basically a sequence. It's an ordered set of values. Now, you can have even strings in a list. So I'm going to run this, execute it. You can see right here. Boom, 2, 3, 4, right? And if I want to multiply all the values from the list, I could do it simply by 2 times the entire list. All happens at once, very convenient. What if I wanted to maybe run 2 uppercase on a list, right? But obviously that wouldn't make sense for numbers. But what if I had dog, cat, and a bat? Boom. All of them got, the application of the function applied. They all got the function applied to them, and it was easily written. This is called, higher level abstractions. That's why Mathematica is a good language to teach programming, because if you had to do this in, let's say, C, right, you'd have to do a for loop. And I'll show you what that looks like for a second so you can see the comparison between languages if you aren't, I know some people know C here, but some don't. So, this is what it might look like in C. You'd have a for loop. You'd say here, I'll even show you in Mathematica. So we have a for function, for I equals 1, I is less than length of my list, right? I equals I plus 1. You have a condition, you have an incrementer, and then you have a body to it, and I'd have to do list element equals uppercase. It would look like a whole clusterfuck. So the idea behind a functional language is you get to transform huge data structures in an easy way where the same kind of operations can get applied to the whole list. And that's a really powerful concept because we can then do other things, like we can apply maybe characters on top of that other function, and we get a list of lists. Yeah, a list can contain a list. Just like we had numbers at first, then we put strings in our list, and now because we're applying characters to each element of our list, we'll have a list of lists of characters, right? It's called a multi-dimensional list, 2-dimensional array. So there's a lot of names for lists. Let me pop up the Mathematica docs real quick, and I'll get you the page on lists just for reference, and then we'll end in a little bit. There's a lot of parts to this, but I think probably starting at making lists of objects would be the first pointer if you did have. And I'm sorry I posted in the announcements before. I just didn't realize I wasn't posting in general. I'll move everything to general and then I'll pin it, or I might just put it in recorded seminars. Okay, sorry, I got a little screwed with. So this is a multi-dimensional list, but there are different names for a list. A list is also the same as an array. Array is more commonly used in computer science, whereas list happens to be used in like Mathematica and just common language. But they are essentially the same things. You might also hear set, but usually a set isn't ordered, whereas here we have an actual order to our elements. So useful thing about lists is clearly the fact that you can iterate, you can basically perform a function on every element of the list. And you basically, that's the basic types. You have lists, you have strings, and you have numbers, and each of those can be assigned to variables in the same way. So, you know, I could do x equals, or let me do my list for better explanatory purposes. So if I did my list, remember, colon suppresses output, but I can always just type my list, and boom, you know, I've got it here. Now, what's the use of a list if you can't pick individual elements out, you might ask? Well, you can. And it's actually really nice the way Mathematica has it done. It's actually the most concise list and most powerful list accessing I've seen in a language, or array accessing, whatever you want to call them. For example, if we want to get the first element of this list, well, first of all, let's look at the length of the list. What should the length be, guys? 3, right? You have 3. The list has 3 elements. Each one is a list, but there are only 3. It's right there. And of course, the length of our original list is also 3, right? So maybe a little weird looking, sort of like nested list, but it makes sense to be able to have a list of lists. You could go any depth. You could have a list of lists of lists of lists of lists, and that may be useful for, let's say you're doing like a tesseract in 4-dimensional space. You'll have like, you know, you can make a checkerboard with a list of lists. You can make a cube with a list of lists of lists. And if you want to go higher dimensions, you need more nesting. Okay, so we can get a length. What if we want to just grab the first element, right? So that'll just be these. So the same way we called a function, we'll actually do 2 brackets. That's a list access. Now, if you don't want to remember the syntax, if it confuses you, there's double brackets. That's fine, because there's actually part. I should mention that if you highlight a symbol, for example, like the % sign, you can actually F1 it and get the docs for it. So it's not just functions. You can do F1 after highlighting a symbol and get information. And a lot of these symbols and a lot of these functions have multiple ways to use them. They could take 1 argument, 2 arguments. If they're, you know, might be a different, the first, if you have 2 arguments, they might be swapped, or so on and so forth. So I'm going to show you, we have this way to get the first element, but let's also use the part function. I'm going to pop it up again. Anyone, did you have a question? Okay. So the part takes the expression, which is our list. So we'll do my list, right? We want to grab the first element. So it's just 1. Boom. Same thing. If we want the second element, do it like that. Want the third element, do it like that. What's even cool is we can actually get the negative first element, meaning we're going from the back. We're starting here. This is negative first element. And you may not think it's useful right now, but it actually turns out to be really useful. For example, if you want to get, let's say we want to get the last element, the last character of a string you put, right? So let's write that right now. This will be the last exercise. And would you guys rather do it yourselves, or would you rather me write it? Last character of a string that someone inputs.
I'd like to try it on my own first.
Okay.
Yeah, same here.
All right. So the functions you'll need is you'll need part, of course, to get the negative first. You'll also need string, or you'll need characters, and then input string. So I'm gonna put those. Let me put those here. Yeah. So you'll need characters, you'll need part, and you'll need input string. But that'll do it. Then you should be able to grab that last character of the string that you put in. And then once you guys do it, I'll write the answer. I hope these exercises aren't too boring either. I'm trying to make it sort of fun and not mathy, but you know, when you're dealing with like basic data, you can't really be doing something too exciting. But in the future seminars, we'll try to manipulate like sounds, graphics. We'll actually make like a game where if you click a button, things happen. Things that you'd want to do, you know, like pull the first result off Google, where like you ask the person to enter a search, and we'll pull, you know, the first result from whatever they ask to search for. So it should get more fun, more applicable as we get further.
I think it's still nice getting some hands-on practice with the syntax.
Right, right. That's what I hope for, you know. I can't jump into the crazy stuff right away.
I got my solution.
Nice.
Oh, by the way, I think I discovered something that if you wanna even go deeper into a list, if you wanna get that like single character out of the list inside the list, all you gotta do is just add another double open brackets and just put another number there. Let me just paste that on this.
I know what you're talking about. It's
Yeah, something like this.
Something like this. That'll grab the T. Or sorry, my bad. This will grab the T.
Yeah, I mean either like that or
Yeah. So this part function, which is the same as double brackets, it's the same thing, by the way. There's a lot of things in Mathematica where you can use a symbol, or you can use a function name. It's just verbosity, you know, how much you want to write, whether you want to make it cryptic to someone who doesn't exactly know the language. But yeah, the part syntax is really powerful. That's why I showed you the -1 thing at least, so you can sort of see that. But yeah, you can grab as long as you know a specifier for the depth and for the order of what you want to grab, like if it's the 10th element in the third nesting, you can do that. So if we want to grab this O in dog, that's going to be the first list, second element. So it would be 1, right? First element, first list inside, second element, and we get the O. And we could actually even grab 2 characters. What if I want the second and the third, the O and the G? Boom, I put a list to specify I want 2 things. OG, isn't it OG?
yeah. It is. So the whole purpose behind the negative indexes, if you have like a really long list, you don't want to actually use a, I don't know, big number to address an element at the end of that long ass list. You just use the negative to just get to the end and
right, and you could
start from the end.
Yeah, and we could do that the other way, which is what you're talking about with the big number. Like we could have, if this was a really long list anyways, we could have done give me the length as the, because that would be the last one.
Oh yeah,
right?
or length -1 or something.
Well, here the list indexes are not like C, they start from 1, so it's a little bit more human.
Oh, okay.
Yeah, but that's why you'd use length, because this is if we did the length of our list is 3, right? So you know we could have done 3. We could also do -1. But yeah, you're right. It's for concise purposes. It's just nice to have, and a lot of languages don't have it. So you literally, if I want, let's say, the element 2 from the back, I'd literally in C I'd have to do length of my list minus -1. You know, I don't want the last, I want the second to last. And I don't know, it just looks a lot more appealing to just have this, right?
Exactly.
Okay, so let's write the solution right now. So we want the input string, and then you guys could check, I guess, what you got if it's similar. So we want to get the characters of the input string, and then we want to pull off the last element, and we could even put a message. And we get E. And that's it for today. We covered types, we have lists, strings, numbers, we covered functions a little bit, defining our own, which is not really going to be too necessary for you to get some mileage right now, but we covered functions that are part of a library. Those are going to be immensely useful, doing all kinds of different things. And then we covered logic. If you you have an if statement, which is actually just a function with 3 arguments: condition, what to return if it's true, and what to return if it's false, and then just a bunch of taking input and manipulating it. The last thing I should leave you with is I guess maybe something cool, which is dynamic. So let's do dynamic, and I'll show you. Actually, let's do odometer. Oh no. Oh, control objects. There we go. So these are all the different widgets that you can use. So like, let's say you wanted to make a game or you want to make something interactive. You can put elements that can be interacted with. But I just want to show you something nice. So it's dynamic, and where's the? There's supposed to be a gauge. Oh, I think it's called gauge. That's what it is. Yeah, gauges. There we go. So we're gonna use a angular gauge when we do that. Dynamic angular gauge x. Alright, so we have our x right there. Okay, so let's set x to 0.5. Ooh, gauge moved. How about 0.1? Ooh, moved again. What if we want a slider so we can manipulate x, so I don't have to keep fucking assigning values? I think that's it. Boom. Oh wait. See, I don't know everything. Gotta check the docs real quick. Slider. Well. Oh, okay. I know why. It's dynamic. X. And I should have done this. I think I've got to put it on the inside. Ah, there we go. As you can see, you can have interactivity, having things happen based on other things. This is just a simple demonstration to show you the power. If you wanted to do this in Python, you'd have to kind of, maybe if you had notebooks you could do it, but most of those notebooks don't have these kind of features. You'd have to fucking save images to the file system and then like open them in like Windows preview, viewer, or open a, you know what I'm saying. The idea here with this notebook thing is that you can create objects and widgets and interactivity without this hairiness of learning like Unity or something, which is great though. Unity is awesome, but for beginners, I think this is really cool.
Yeah, man, you don't have to even go through like, in Java there's like OOP involved, and you have to like write a separate script for what's going behind the scene, the logic, and you gotta write another script for doing the graphic user interface.
Right.
So
it gets
it
real
just
hairy
saves-
for beginners. Yeah. I can't blame most people, because when I learned Java AP in high school, well, I already knew Java. I did all the classes homework and made some nice money. But the professor, or I guess you call him teacher because it was high school, but he's trying to get people using Swing and shit to make video games, and it's like no wonder these people are all depressed and getting other people to do their projects who actually know coding already. Because how can you teach beginners and then teach them all this hairy implementation specific shit? Like, if I want to have fun with a tractor, I don't want to learn everything inside the fucking engine and like carburetor and all this. I want to ride the thing. So I can't blame most people for like dropping out of the way programming is taught these days. It's the wrong languages. It's the wrong like assignments. But I hope you guys enjoyed. I don't want to do any more monologues. Any questions? Any comments? Please feel free to DM me or say them now. Can we get a little discussion about any of these things right now for a minute or two?
I enjoyed the course. I'm looking forward to the next one.
Awesome, thank you.
Yes, here.
Same.
Oh, just one thing. You mentioned this thing called scopes. Is that the equivalent for pointers or something? Or
So Mathematica doesn't have pointers really, or at least they're more hidden. But scopes is going to the only reason I use scopes is optimization. You really like having variables be global. I mean, I always forget what is it? Radical. What Radical's asking about is when we like set these variables, my list, just anything with a name, right? We set X over here. Where can they be accessed? And well, within this notebook, right, you can access them anywhere. Even like I can access X inside this function, right? So I could have put like X plus this and it would be fine. But there are ways where you can write a variable so that once your function ends, your variable is gone. And the only reason I do this is like you want to save space. You want to be a little bit neater. You don't have all these like global variables, but it's really not something to worry about now. Just use, don't worry about scopes. It's an optimization thing. Yeah.
All right then.
Yeah, the way old programming languages used to work, even like all the computers that had C on them, is for every variable, a piece of memory was reserved, even if the variable is only used like in one tiny place at the beginning of the program, like on startup. That variable would still exist and it would be reserved, and that worked for a long time just fine. So it became an optimization thing to like, oh, I don't want this variable anymore. Leave it, get rid of it. Make it go away when my function ends. It was just temporary calculation, All right, guys. I was hoping to have an assignment for you, but I don't have it right now. But I may try to make one and send it the next day or two. Yeah, I hope to see you guys in the next one. Hope you guys enjoyed.
All right.
Oh, and if you attend 3 seminars, I'll hook you up with a copy of a full version of Student Mathematica, which is basically the same as normal Mathematica.
All right. So the session you're having tomorrow is the same as this one, but what's the actual, when's the actual next session?
See, the thing with this session is that I actually tried to have this session a week ago, and literally no one showed up. Because all the schedules were fucked up. So I sent those schedule kind of surveys and found out like there were 2 time slots that people, like half the people were available for this one and half were available for the other one. So this is when I scheduled it. But I would assume that these times and dates would be good. But I think I'm just going to send out a survey for the second one, and if they end up being pretty similar to this one's times, we'll just stick to these 2 times, because it's easy to do back-to-back 2 days,
All right then.
But yeah, next session will probably be like in a week or so.
All right. Seems pretty good.
All right. If you guys
have Friday.
Sorry, what's that?
Was it, the announcement says there's one Friday, no?
There's the same exact session tomorrow.
Oh,
for
that
people
echo.
in the UK.
Oh, okay.
Yeah, it's just redundant because those people in Europe and Asia, they couldn't make this one. So I'm doing the same exact one tomorrow at whatever that time I listed.
All right.
All right then. Sounds good. I'll be off if the session's over. Thanks for the.
All right, I'm gonna hang around here to answer any questions if anyone has them. I'll be hanging around here for the next 10-15 minutes.
All right, see you guys here.
Thanks for coming, guys.
See ya.
Will there be recording of this session?
Yeah, it's
on your Twitch channel.
It's on Twitch, and I put VODs, so
right.
there should be a recording. I'm gonna end it now.
All right. Just want to know. Thank you.
Mhm.
It was a good session, though. I liked it.
Thank you. I appreciate the feedback. It's a little intimidating doing my teaching a bunch of more than a bunch of people when I've sort of only tutored people like 1 or 2 at a time. It's a little different kind of flow.
Well, I could imagine.